Hi, let's learn about simplifying some radicals. The first number I'll take is a square root of 16. What's not always written but assumed is the index number of a square root. That means there's an actual 2 there, but we don't always write it. Okay, the first thing I'll do to simplify this radical is to factor or list out all the factors of 16. I know that to be 2 times 8. My 2 is a prime number, so that could be left alone, but 8 is not, so I'll keep going. 4 is not, so I'll keep going. So if I were to list out all of the factors horizontally, I've got 2 times 2 times 2 times 2. So 2 times 2 times 2 times 2. Because my index number is 2, or it's a square root, that means every set of 2, 1 will come out. So 2 will come out, and another set of 2 is here, so that extra 2 will come out, and these will be multiplied together. So that means my answer is 2 times 2, which is 4. But remember that it's also expressed as plus or minus 4 because 2 times 2 times 2 times 2 is positive 16, and that's true. But negative 2 times negative 2 times negative 2 times negative 2 times is also positive 16, and that's also true. But from here and on, I will only assume my answer to be positive real numbers, so we won't deal with this anymore. Let's take the same number 16, but this time we're going to cube it, or with the index of 3. I already know my factors of 16. That was 2 times 2 times 2 times 2. But instead of taking a set of 2, I will take a set of 3, and 1 will come out of the radical. I still have a single 2 left in there, so my answer would be 2 times cube root of 2 as my final answer. Don't forget that index of 3. What if I have a negative sign in front of the square root of 16? We're back to square root. I already know the square root of 16, but just a side note, negative square root of 16 really means negative 1 times square root of 16. So that's the same to say negative 1 times 4, because square root of 16 is 4. My final answer would be negative 4. So if that negative sign were to be inside the square root sign, that really means 2 times 2 times 2 times 2 times negative 1. And on a side note, square root of negative 1 equals to the imaginary number of I. So that means I've got 4 times I. If you feel like I skipped a step, this really means, again, taking every set of 2, 1 comes out. So that's 2 times 2, that's 4. Then I still have my single negative 1 in there, so square root of negative 1. And as noted, square root of negative 1 is I, therefore my final answer is 4 times I. Final answer. Okay, let's practice with some other numbers. If I were to take a number like 50, square root of 50, that's 5 times 10. 5 is a prime number, so that could be left alone. 10 is not, so I'll keep going. So I'm left with 5 times 5 times 2 as my factors of 10. Again, unwritten, but my index is 2, so every set of 2, 1 will come out, meaning my answer will be 5 square root of 2 as my final answer. If this were cubed, cube root of 50, I don't have any set of 3's of any number, so it would just remain as the most simplified as is. Okay? Let's move on, just so that we can get more practice. If I had a number like 162, let's list out all of the factors of that. I don't know whenever I see a big number like this, so because it ends in an even number, I know that it could be divided by 2. That leaves me with 81. Then I know that this is 9 times 9. If you know that any set of 2 numbers can be used, we can stop there. So let me try that this time. So I know that it's 9 times 9 times 2. I know that these are all prime numbers, but this can still work. If you see a set of 2 numbers, that's still the same. So it just saves us some time. So I see that my index is 2 because it's a square root, and I see a set of 2 of 9s, so that can come out. But this 2 remains here by itself, so my answer would be 9 square root of 2. Let's do some cube numbers. So cube root of 24. My factors of 24 are 2, 2, and 3, 2. All right. So I've got 3 times 2 times 2 times 2. Again, my index is 3, my cube root, so that means every set of 3, 1 comes out. This guy is a single, so it will remain in here, meaning my final answer is 2 cube root of 3. Don't forget that. Don't forget this. My final answer. If I had a negative in there, let's say I take a cube root of negative 24, this means 3 times 2 times 2 times 2 times negative 1 times negative 1 times negative 1, because that still gives me negative 1. You feel me? So I will take a set of 3 and 1 will come out. It will take another set of 3 and 1 will come out. Again, 3 is a single, that will remain in there. So I've got negative 1 times 2 square root of 3. So my final answer, negative 2 square root of 3. Cube root of 3. Pardon. My final answer. If I take more funky numbers, let's do negative square root of negative 49. That's 7 times 7, and I can stop there. So negative 1 times square root of 7 times 7 times negative 1. Every set of 2, 1 can come out. So it would be negative 1 times 7 and square root of negative 1. And as a reminder, a square root of a negative 1 is just I. So my final answer would be negative 7i. And just like cube root of any number, or if it were a 4 in here, or even 5, or 6, or 7, it would be the same way. So let's take an example of that. Okay, let's take a bigger number and a bigger index, like 5. First thing first, I will factor this. I'm going to try to divide by 9. That's that. Let me see if I can divide this by 9 again. 12. Okay. All right, so we got this. That's 3 times 3. 3 times 3. And that's 2 times 2. Let me list this out. So I've got 2 2s. And I've got 1, 2, 3, 4, 5 3s. 1, 2, 3, 4, 5. Okay, because my index is 5, I will take every set of 5. So I remember having 5 3s. So 1 3 will come out. And unfortunately, I only have two 2's, so they will remain in there. So my answer would be 3 radical 2 times 2, which is 4. And don't forget the index. That's my final answer. So these are some ways of simplifying basic radicals. If you have any other requests or questions, you can leave it in the comments or message me, and I will explain them or solve them.